Okay, so for the first question, there's a few clues if we can't remember anything. You've got light-dependent resistor and light-emitting diode. So if we see on there, there's light coming in, light going out. We know therefore that this one either goes to this one or this one, and this one goes to this one or this one. The second clue is this resistor R. So R stands for resistor. R also stands for rectangle. Okay, so you've got a rectangle with some light coming off it. So you know that R, resistor, rectangle. Therefore, this one must be this one. Now, this bit is the bit that's a diode. So this one looks nothing like it, and you should remember that that one's a lamp. Second question. Hopefully you should all remember that's a cell. Nope. You should remember that's a switch. That's a cell. And this is a diode. Remember, cell is one, a battery is two or more. Okay. Next question. Write one of the following. Which one of the following is the correct circuit symbol for an LDR? Draw a ring around your answer. So if you remember, R, resistor. Okay. Now name one factor that will affect the intensity of the light hitting the LDR. Okay, so we might need to read the whole question. A student used the apparatus below to find out how the resistance of a light-dependent resistor depends on the light intensity. The resistance of the LDR was measured directly using a multimeter. Now this is a common sense answer. So if you put a torch close to your eye, the light's going to be more intense, it's going to be brighter. Or if you put a torch closer to an LDR, the light's going to be more intense and brighter. So the distance between the torch and the LDR is the factor that will give you 1 mark. Next question, again, remembering our trick questions. Light, 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 light. Okay, now resistor, rectangle. The other light one, therefore, must go to the light emitting diode. Thermistor is a temperature sensitive resistor. Hopefully everyone should get that that's a switch. And we'll do the fuses in the next topic, but a fuse is effectively a resistor that protects a circuit at higher currents. Now this is a really easy question, but it's really easy to mess up on the exam. So, Reese correctly uses the circuit shown below to investigate the behaviour of a thermistor. He takes a photo of the circuit on his phone. He places the thermistor into a beaker of hot water to start the experiment. There's the photo. So, complete the circuit diagram of the circuit he used. Now, it's easier to hold them next to each other. So, there's two 9-volt batteries, 9 volt, 9 volt. Let's cross that one off. Thermistor, thermistor. Cross that one off. Now, if we follow this around, the only thing left to draw on is an ammeter. So, again with a pencil and ruler, I'm going to draw a nice big A for ammeter in a circle. Doesn't matter where you put it, as long as it is connected in series. Remember, ammeters are always connected in series, voltmeters are always connected in parallel. Join everything up with a ruler. Again, you can do it about 10 times neater than I can. Okay, so you've got an ammeter connected in series. As the hot water cools, the reading on the ammeter is recorded in the table below. Plot a graph using the data on the grid provided. So we've got our independent variable, independent variable, dependent variable, dependent variable. So I'm going to go 100 degrees is 200 milliamps, all the way up there. Again, small mark with a pencil. 80 is 140. 60 is 100. 40 is 70. 20 is 50. Now, this isn't going to form a nice straight line. If you remember, the shape of the resistance graph for resistor is a curve that goes down. So if we were measuring temperature up there, temperature on the bottom and resistance, we're going to have a curve down. However, we're measuring current, so the curve is going to go up because the resistance is a lot less. So again, you would draw a nice straight curve. There we go. Not dot to dot. The next question then, describe the relationship between the temperature of the thermistor and the current. So let's get our graph. So temperature and current. Now we always start with, as the temperature increases, the current, then we say increases or decreases. So as the temperature increases, the current goes up. So 1 mark would get you, as the temperature increases, the current increases. Now, there's lots of different ways you could then describe the graph. If we fitted a ruler to it and it was a nice straight line, you could say there was a constant increase. If it was a straight line through the origin, you could say they were directly proportional. In this case, the increase is a curve, so it's a non-constant increase. The current is increasing much more rapidly at higher temperatures. So for the second mark, you would need to comment on the fact that the current increases at a much greater rate at higher temperatures. Next question. Explain how this circuit can be used to indicate changes in temperature. So we set this up. 2 lamps, thermistor. We know that the current increases at higher temperatures. We also know that this is a series circuit, so the current is the same everywhere. Therefore, we know that we would set up a series circuit. The current is the same at all points in the circuit. There's a thermistor present in the circuit. The current will increase through this thermistor as temperature increases. If the current increases through the thermistor, the current will also increase through lamp A and lamp B, because it's only got one route to go around. However, if the current is larger in the lamps, they're going to be more powerful. You don't need to remember this because it's in the formula sheet. P equals I V, P equals I squared R. Okay, so they're going to be more powerful if the current's larger and the voltage remains the same. So the voltage supplied is the same, current gets bigger, power must get bigger. Forgetting those, you could just say the lamps would be brighter because the current is higher. You need to mention that you would see the lamps get brighter as the current increased, as the temperature increased. Lamp B breaks, explain what would happen to lamp A. Now again, it's 2 marks. So you need to mention that they're in a series circuit. Current travels in one path, in one loop. If lamp A breaks, the circuit will be incomplete. Current can no longer flow to lamp B. Lamp B will therefore go off. Lamp A will go off if lamp B breaks. Next question. Now, this is the long answer question that I think is going to come up. So, describe how you would investigate the resistance of a filament lamp changes with voltage. 6 marks. We used our sheet before with the 6 boxes on. I'm just going to go straight in and do it though. So we need to remember the circuit we're going to draw. We need to draw either a variable power supply or a variable resistor within our circuit. So I'm going to opt for drawing a variable resistor. So I've got my variable resistor and a power supply. I also then need to figure out which component. It's asking me for a filament lamp. Draw a filament lamp in. Now I've drawn my filament lamp in. I need some way to measure how the voltage changes. I'm also going to need a way of measuring how the current changes. So if I do the current first, I need an ammeter connected in series. I'm also going to need a voltmeter connected in parallel. Let's connect these up. Again, I'm doing this really awkwardly over a pile of books, so yours is going to be about 10 times neater than mine. Now this is an important experiment to remember. I want you to investigate how the resistance of the filament changes with voltage. So, because it's a series circuit, the current is the same everywhere. However, the voltage will split over the two components. If I alter the resistance in the variable resistor, the voltage will go up. Therefore, the voltage may go down there if it's the same voltage supplied in the battery. So if I got 6 volts in, and I made this have a resistance that gave me a voltage of 4 volts, this one would have 2 volts. If I change this to 3 volts, this one would then have 3 volts. So you need to link in your answer, you need to link resistance in the variable resistor will alter the voltage across the bulb. So if you vary the resistance in the variable resistor, you will vary the voltage across the bulb. So vary resistance varies voltage. Now it's important to say what we're going to measure. You're going to measure the current, and you're also going to measure the voltage. You may wish to say how much you want to vary the voltage by. You may want to vary the voltage by 0.5 volts, 0.1 volts, etc. You then repeat. Then, when we've done this, we plot a graph of our results. So you plot a graph of voltage against current. When we've got this graph, we need to analyse the graph. So you would calculate the gradient, which is the slope of the line. R equals V over I, which will give you the resistance of the lamp. Okay, now this is a QWC question, so 6 marks. I've bullet pointed things to include in your answer, but you need to make sure it's a well-written paragraph that says you use the variable resistor to alter the resistance, which alters the voltage across the lamp. You record the voltage and the current. You repeat. You then plot a graph of voltage against current with your results. You calculate the gradient of the graph, which will give you the resistance of the lamp. So, things to check. You need to go back to the question. Have you got a labelled diagram? No, I haven't. So I need to label my diagram. And I would write cell, ammeter, bulb, voltmeter, variable resistor. How you would obtain a range of results. You may want to then include, I would vary the voltage by 0.5 volts from 0 to 6 volts. That would give you a range of results. So I'm checking my answer. Need to add range. Okay, how would you analyse the data? So I've said you calculate the gradient, which will give you the resistance of the lamp. Okay, but it wants changes with voltage. So how gives you the resistance of the lamp and how this changes with voltage by calculating the gradient at different points. Or voltages. Okay, so we did a lot of work on this in class. I've marked your answers. This is just a brief summary. Now, next question. Two identical lamps each have a constant resistance of 8 ohms. So, first thing I do, circle the 8 ohms, stick an R next to it. It's connected as shown in the circuit with a lamp of a power output of 18 watts. Circle that and put a P next to it. Okay, now I know I'm going to use P and R. Use an equation from page 2 to calculate the current through the lamp. So I circle current, put an I. Remember, CIA, current in amps. So the current has got the symbol I and the unit A. So use the equation from page 2 to calculate the current in each lamp. So we're going to this time do P equals I squared R. This comes directly from looking at P, R and I. I then use my formula page to find an equation with P, R and I in it. P, R and I, P equals I squared R. Remember, this is why we circle it. We circle it to find the letters we need to find on the formula sheet on the front of the exam. Now, P equals I squared R. I now need to rearrange for I squared. If it's a times on this side, it's going to be a divide on that side. So P over R equals I squared. Let's do that first. So we're going to have 18 divided by 8 equals I squared. 18 divided by 8. Gives me 2.25. This gives me I squared, not I. So I then need to square root 2.25. Gives me 1.5. My final answer is 1.5 amps. The tricky bit is finding out what equation to use, P, I and R. Find that equation because we can also have an equation with P, I and V in it. Now this next question, write down the reading on the ammeter. This requires you to remember that in series the current is the same everywhere. So if I had a lamp in series by there and by there, the current would be the same. However, in parallel, the current has a choice of roofs and splits. The important other information is two identical lamps. So if I know that this is 1.5A, remember you can write on there, this one is also going to be 1.5A. 1.5A and 1.5A join up. So when I get to the ammeter, 1.5 and 1.5 join to make 3 amps. Can you see that this is 3 marks? 1 mark would be for that. 1 mark probably for that. 1 mark for that. And the final answer. Now use the equation V equals I times R to calculate the voltage of the battery. So I know R equals 8 ohms. I equals 1.0. I almost did it. There's 1.5 and 1.5. Going through the battery, we're going to have 3 amps. Okay? Because through the battery, the 2 bulbs, the current is rejoined, 3 amps. And V is unknown. Again, you go to page 2 and find the equation with R, V and I in it. Now, V equals I times R. You'll get it in the formula sheet as R equals V over I. To get V on its own, you've got I on the bottom, take I up. If it's divide on this side, it's now times on that side. So V equals I times R. Voltage is current times resistance. So therefore, I just plug my numbers in. V equals 8 times 3. The voltage is 24 volts. 2 marks. One for that and one for that. Okay. The same two lamps are now connected in series with the same battery. Explain why the ammeter's reading has decreased. Okay. This is because it was quite a difficult topic when we did it, but the total resistance in series, you added them together, didn't we? Now in parallel, we added them as 1 over. So explain why the ammeter reading has decreased. You need to mention that they're in series, now not parallel. You sum the resistances as 1 over R, not R plus R. So you add them as 1 over plus 1 over. Therefore, the resistance is larger in series, making the current smaller. So you could leave out this bit. Just say it's series now, not parallel. Resistance is larger in series, current is smaller. You could even write R equals V over I. Okay, so a larger or you could write that as I times R equals V. There's the same voltage applied, same battery. If the resistance goes up, the current must come down to make that the same. I would put the equation in there somewhere if you could, okay? Now, calculate the power dissipated by each lamp in the circuit. So, the power can write P equals I squared R, or P equals I times V. Equally, we know the voltage of the battery, which would split in half. So we'd have 12 volts and 12 volts if they were identical, which they are. So we could work out it from V, P equals I times V. However, I would be tempted to use this equation because you're given R in the question. R equals 8 ohms. We know that for each lamp. We know that. We haven't had to work anything out. We couldn't have made a mistake. So R is 8 ohms. I equals 0.75 amps. And we want P. So I do P equals 0.75 squared times 8. So let's do 0.75 4.5. Okay. Give a reason why the lamps are connected in parallel rather than in series in domestic circuits. Okay. In domestic circuits, your light bulb breaks. One light bulb break in your house, say the light bulb in your kitchen broke and someone was in the shower, a light bulb in the bathroom would also break if it's in series. Therefore, they're connected in parallel, because if one lamp breaks, the rest don't go out. Okay, next question. The diagram shows a lamp connected to a battery and a variable resistor. Describe the circuit used to measure the voltage across the lamp. Describe how the circuit is used to obtain a series of measurement of the voltage across the lamp. You should add symbols to the circuit and additional components. So this is 4 marks. They are identical. Those two questions, one's 6 marks, one's 4 marks. They've given you a little bit to start with. You need to add the rest. Okay. The results from the lamp for the lamp are shown in the graph below. The resistor has a resistance of 4 ohms. Draw a line on the graph above to show the current through it and the voltage across it up to 12 volts. Okay. Now, we know that we're going to go up to 12 volts. So we're going to stop there. And we also know that because it's a resistor, the shape of the graph is going to be a straight line through the origin. However, we do not know which point of the current to go to. So I've got R, I've got V, I want I. V equals, R equals V over I equals V over R. Three amps. So I find a point where I've got 12 volts and 3 amps. Use a ruler. Straight line through the origin. Again, I'm doing this a bit awkwardly because I can't really see anything. Point there. 3 marks for a straight line, as long as it goes to the right point. Now, use the graph and an equation from page 2 to find the power of a lamp when it has the same resistance as a resistor. Now, we know that R equals V over I. So if it's got the same resistance, it has the same current and the same voltage, or multiple. So it's got twice the voltage and twice the current, 3 times the voltage and 3 times the current. Essentially, it's the point it crosses on the graph, which is going to be 8 volts and 2. I worked this one out as 2.2. So it's got 8 volts, 2.2 amps. So V equals 8, I equals that. It might be slightly different because I'm drawing it a bit awkwardly. Now, P equals I times V, because you want your power. Okay, times them together, you end up with 18.4, I think. $17.6. Now compare the resistance of the lamp when the voltage compare the resistance of the lamp and resistor when a voltage of 12 volts is applied to each. Give a reason for your answer. So you need to remember that the resistance of the filament lamp increases with voltage because it increases with temperature. Therefore, the resistance at 12 volts of the lamp is greater than the resistance at 12 volts of the resistor. We know this from the graph because the gradient is shallower. This may be because the lamp is hotter. But for the 2 marks, you need to mention that the resistance is greater in the lamp because the gradient is shallower on this graph. Now this one, Two filament lamps X and Y are connected in series. Lamp Y is brighter than lamp X. Choose and write down an equation from page 2 to explain why lamp Y is brighter than lamp X. Okay. Brightness is related to power. So we could write two equations for power. I times V equals I squared R. Now, they're both the same. How we would use the equations, I mean. Now, if the current's the same in series everywhere, okay, so because it's a series circuit, the current's the same everywhere. That's the first line. So I'm going to bullet point this because everyone will have different answers. Current is the same everywhere. Same at all points. Now, there's two ways you could explain this. It says that lamp Y is brighter than lamp X. Lamp Y is brighter than lamp X. I would tend to use this equation because you can talk directly about resistance. Lamp Y is brighter than lamp X because it has a greater resistance. So lamp Y, greater resistance. Therefore, lamp Y is more powerful. This is 4 marks. You could also link that back to voltage if you wanted to, and say that the voltage supplied, because this one has more resistance, will split, and this one, lamp Y, will have a greater voltage because the voltage will split over the two components because there's a larger resistance. You might also then need to bring in R equals V over I to explain that. I'd stick to this equation and say that in series the current's the same at all points. Lamp Y has the same current as lamp X. Lamp Y has a greater resistance, therefore lamp Y is more powerful, therefore lamp Y is brighter. Final question. A light fitting consists of 12 40-watt lamps connected in parallel. They're connected to a 230-volt mains in a circuit in series with a single dimmer switch. So they're all connected in parallel, but the dimmer switch connects to them all because it's in the series part of the circuit. Use an equation to calculate the current through each lamp when all the lamps are operating at normal brightness. Okay,